Okay, guys, so today we're going to be looking at proportional relationships and setting up all of the characteristics and talking about everything we can about proportional relationships. First thing you're going to do is take this piece of paper and we're going to cut out all of the pieces. So I'm going to pause this for a minute and we're going to get these pieces cut out. Make sure you keep them separated as proportional, non-proportional. Okay, I've got my pieces cut out. And so now I've got to draw me a circle. And so with your pencil, you are going to draw a circle. And I want you to see how I draw mine because you do not need anything to trace, but you do want to draw you a circle that is as big as you can get it on this piece of paper. So we're going to get it. We want to do it as big as we can, but before we do, let's go ahead and do our frame. And you want to put your frame as close as you can get it to the outside edge of your paper without touching the edge of the paper. But we do need a frame. Every map has a frame of reference. We don't utilize it all the time, but the paper is not the frame. So we're going to draw us our frame. My paper doesn't fit right here real good, so I'm having to shift it around. So here's my frame. And now I want to draw me a nice big circle. I'm going to just start right here and come around. And it doesn't matter if it is a little more egg-shaped than round. And so here's my circle. It looks a little bit like an egg, but that's okay. And because my circle looks like an egg, I'm going to use my paper this way. Now you can set yours up either way. It doesn't matter if you use it portrait or landscape, as long as you get everything on it. I'm going to do mine this way because my circle is longer that way. Okay. I also need to go ahead and get my pen. Proportional relationships right here in the middle, because that's what we're doing. Proportional relationships. Okay, and then once I get that in there, I'm going to draw my circle around it. All right, so that is ready to go. Now we're going to be looking at all different types of proportional relationships. And some different, we're going to look at examples and non-examples. So what I'm going to do is take my pencil and I'm going to kind of I want to kind of divide my circle into 3 parts. So that, and I'm going to extend that line all the way out like that. I think I'm going to pull this one down. Actually, let's come from this corner. I'll come from this corner straight up. There we go. Doesn't have to be perfect. And then I'm going to come from this back down to this corner. So I've got 3 sections, okay? Those 3 sections are going to be, we're going to look at right here. I'm going to put equations. I'm trying to see if I'm getting this on the paper. Equations down here at the bottom. And then up here on the top left, I'm going to put my tables. And over here, I'm going to have graphs. All right, let me see if I can pull this camera up. Okay, I tried to reposition that a little bit, but now these pencil lines are fine to just be kind of light pencil lines. So let's start with our tables, all right? So we have this one. And this one. Okay, I'm gonna pull that one up some. Pull that up. All right, so look at those two really close. Make sure the ones that you get, that you grab, are those 2 tables, but to start with. And we're gonna go ahead and glue those down. Let's get those glued on here. Now guys, this is probably the most important part of this unit, and understanding what we're going over today is critical to your success in this unit. So I need you to watch this, rewatch this. It's got, you've got to get this in your head. So what we're actually, all right, we know that a proportion is 2 equal ratios. And what we now have to determine is if these 2 tables show us a relationship that is proportional, okay? So we know that a proportional is 2 equal ratios. So let's put in our right here, right in here. Let's write that right there and remind ourselves that a proportion is 2 equal ratios, okay? So, 2 plus, let's do 2 plus, because it's really 2 or more equal ratios. So 2 or more equal ratios. And the way we're going to determine that is we're going to look to see, does this table make an equal ratio? And the way you're going to do that is you're going to use the ratio K over X, because K is your constant. K is the variable that represents your constant of proportionality, your unit rate, all of those things. So we're going to be using the ratio. So over here under tables, I'm going to put use the ratio K equals Y over X. All right. K is your constant of proportionality. We're going to do another circle map to talk about all the ways to say K, but right now what you need to understand is K represents, K is your unit rate. It is your constant of proportionality. K is your unit rate. K is your constant of proportionality. Okay? K is either one of those. All right, so I'm just kind of squeezing that all in there. I need you to understand. I need you to understand, this is critical, that this is a ratio. To find K, you are using a ratio. Down here, when we talk about equations, it's something totally different. This is a ratio. We're referring to this as a ratio. That looks like a fraction, doesn't it? Yes, it is a ratio. We're going to call it a ratio to try to keep it straight in our brains what we're looking for. So in order to decide if these two tables have are proportional, in order to decide if these are proportional, we have to decide if they have a unit rate or if they have a constant rate of change. And the way to do that is we're going to write these things in these tables as y over x. Now, in a table, this is always x. The left side's always x. This is always y. Okay? In this table down here, the top is always x and the bottom is always y. Okay? So what are we going to do? We're going to take these and we're going to write them y over x, starting right here. So right here, I'm going to put 6 over 2, 12 over 4, 18 over 6. And then I want to work them. 6 over 2 is 3, 12 over 4 is 3, and 18 over 6 is 3. All of these are the same. And if all of these are the same, this table is proportional. So I can put yes out here because K is the same. This is K right here. K in this table is 3. The unit rate in this table is 3. The constant of proportionality in this table is 3 because I just figured it out by writing K y over x. So that is a yes. Right here, let's do the same thing. We're going to write these y over x. So 75 over 1, 150 over 2, 225 over 3, 375 over 5, 750 over 10, 7,500 over 100. 75 over 1 is 75. This is 75. This is 75. 375 divided by 5, you should put it in the calculator, is 75. All of these equals 75. And because all of these equals 75, this is K. K equals 75. We can say yes. K is the same. Okay? K is the same. So those two are examples of tables that have a constant of proportionality, that have a constant rate of change. And because they are examples, I'm just going to quickly shade these two green. You can use your crayons. I'm just going to quickly shade these green to show that they are examples, okay? So those are examples. Now, let's look at a couple that are not. What does it look like if they are not? So now I want you to find these two tables and get those glued down. Uh-oh, I gotta pull it up. This is what we're doing. These two. Okay. Now, so now I want to determine if these tables have a proportional relationship. Do these tables have a proportional relationship? Well, this is X, this is Y. This is X, this is Y. And I've got to use the ratio Y over X. So I'm going to come right here and I'm going to put 100 over 1, 300 over 3, 550 over 5, and 600 over 6. 100 over 1 equals 100. 300 over 3 equals 100. 550 over 5 equals 110. The second, even though this one is 100, this one right here makes this table not proportional. They're not all the same. These are not the same. Those are not the same, so this is a no. Not proportional. Because K is not the same. Over here, let's write these Y over X. Ten over 2, 16 over 4, 22 over 6. Well, I'm not even going to worry with that one, but 10 over 2 is 5. 16 over 4 is 4. The minute there's a difference, I don't even have to divide this one. I don't even have to do anything. Those two are not the same. This is not proportional. Okay, so the second that you hit one that's not the same, you can stop because they're not proportional. So we're going to shade these red to show that they are not proportional. They are not proportional. These are two examples of not proportional. Okay, so again, to find it in a table, you are looking for Y over X. Y over X is a ratio. We're using the ratio Y over X. Okay, so now I'm going to probably have to fold mine around. I just got to get it so you can see it. So I'm just going to fold it over like that. Just a minute. So now let's look at graphs. Let's look at graphs. And we're going to take these two first. And take these two. I'm going to put those down. We'll go ahead and glue them all on. Go ahead and glue the rest of them on there. All right, so there's my graphs. So now let's look at them. The way we're going to do that is we've got to get our ordered pairs. Well, this graph is kind of easy because it gives you the ordered pairs already. And on these ordered pairs, this is X, this is Y. This is X, this is Y. This is X, this is Y. Okay, so I'm going to come right over here and I'm going to write my ordered pairs Y over X. So I've got 2, over 3, 4 over 6, and 6 over 9. All right? So just because I want to be sure I'm doing it right, I'm going to use my calculator. 2 divided by 3 is 0.66 repeating, is 0.6 repeating. 4 divided by 6 is 0.6 repeating. 6 divided by 9 is 0.6 repeating. So, these are all the same. These are the same. If they are all the same, then we can say, so, yes, this is proportional because all of these are the same, because y over x is the same. So that is proportional. All right, so looking at this one. Well, we've got to get our ordered pairs off of here first, or we got to write them on here. So I want you to remember, this is the x-axis right here. This is x. This is x. This is x. And this is y. Okay? This is y. So to read this, I'm going to read on the x-axis and then the y-axis to get my ordered pairs. So to put my ordered pairs on here, I've got to go over and then up. So I'm going to 2 and then to 15. So this ordered pair right here is 215. This ordered pair is 430. This ordered pair is 645. This ordered pair is 860. I'm going over to 8 and up to 60. This ordered pair is 1075. Okay. Now that I have them on there, I want to now write them as y over x. Now I'm going to write them y over x. So I'm going to come over here and write 15 over 2, 30 over 4, 45 over 6, 8 over 6. Sorry, I did that one wrong. Back up. 60 over 8 and 75 over 10. Take my calculator. 15 divided by 2 is 7.5. 30 divided by 4 is 7.5. 45 divided by 6 is 7.5. 60 divided by 8 is 7.5. 75 divided by 10 is 7.5. And look at there. All of those are the same. They are the same. So if they are the same, we know that this graph is a proportional relationship. Yes, it is proportional. Now, another thing that we need to know about graphs that make them proportional. So I'm going to come right over here and we're going to write this right out here. Graphs are also proportional. You can look at a graph and know that it is proportional with two things. One, it has to be a straight line. Two, it has to go through the origin. And the origin is 0, 0. This is your origin right here. This is the origin, okay? So it has to pass through the origin. So in reality, we don't have to do this when we're looking at graphs. All we're really looking for on a graph is it a straight line? Yes. Does it go through the origin? Yes. So let's go down here and look at these a minute. Is this a straight line? Yes. Does it pass through the origin? No, it does not. That right there makes this not, this is not proportional. It does not pass, it does not pass through the origin, which is 0, 0. Okay? This is not proportional. Looking at this one. Let's look at moon and earth. Okay? Is it a straight line? Yes. Does it pass through the origin? Yes. And it looks proportional. But I want to check it. I don't want to just go on that right off. Let's take a second and look at that one. And make sure. I just want to show you that. Let's make sure. So, another thing I want you to notice on these is some of them are not numbered always as, sorry. And, notice how the axes are not ordered. So, this is X, this is Y. So, let's first write our ordered pairs. So, I'm going to go over to 6 and up to, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes it's easier to do that. So I'm going to 6 and up to 1. So this is 6, 1, 12, 2, 18, 3, and 35. Okay, so let's come right down here and write those as y over x. So 1, 6, 12, 2, 18, 3, and 35. And I wrote all of those wrong. Guys, I'm sorry. It's early. Just so y'all know, it's only 6:20. So, y over x. You see that mistake and see how quick it was to make that mistake? Y over x is 2 over 12. Y over x is 3 over 18. Y over x is 5 over 30. The way I wrote it to start with was x over y, and that is a huge common mistake that you can make very quickly without it if you're not thinking about it. So be very careful. You have to write these y over x. All right, so now let's look and see. 1/6 is simplified. 2 over 12 simplifies to 1/6. 3 over 18 simplifies to 1/6. 5 over 30 simplifies to 1/6. All of these are the same. So, yes, this one is proportional. All right, so let's go ahead and take our green and red and just quickly shade this one green because it is proportional. This one is green. Now remember, with graphs, it's kind of easy because you don't have to do what we just did. I did it so that I could show you that it holds true. All you really have to know about graphs is that they have to be a straight line and go through the origin in order to be proportional, okay? This one is not proportional. It is a straight line, but it does not go through the origin, so it is not proportional. This right here is what makes that not proportional. Now let's talk about equations. Go ahead and get your equations glued down. I'm going to pause this for a second and glue mine. Okay, so I got my equations glued down here, and let's talk about what makes an equation proportional. Well, it's really easy. What makes an equation proportional? The equation has to be written y equals, the equation has to be written y equals kx. This right here is the ratio y over x. So when you find your ratio y over x, it goes right here. K is also, this is also your unit rate. It's your constant of proportionality. It's all of those things. But all you're looking for is your equation to be written. It cannot be written y divided by x. It can't be written, it's got to be written kx. All right? So I'm going to put a couple of examples on here that are not. But for example, let's look at a couple. Let's look at a couple right here a minute. So y equals 2x. That is k. So yes, so that is an example of a proportional equation. Okay? So you're looking for y and then a number or something that can represent k and then multiplied by x. So if we look right here at this one, y equals, this would be k, and then here's your x. So this is, yes, this is the equation for proportional, because that's k. K is 3/4. Okay? K is 3/4. Here's your k right here. Look at this. Y equals, we need kx. Is that? No. Y equals kx. That's, no. It can't be subtraction. It can't be division. Y equals kx is what we're looking for. No. Not k plus x. That's what makes that not k minus x. Not k divided by x. It's got to be k times x. And that's what you're looking for